This is Dr. Paul Juris of the Cybex Institute for Exercise Science, here to discuss one of the most innovative and versatile products in the fitness industry, the Cybex Arc Trainer, and the science behind the performance. Before we present the Arc, let's take a look at the reasons for and the evolution of non-impact cross trainers. You can see in this slow-motion video a subject running at 8 miles per hour, and each time his heel strikes the deck, a shock would be transmitted up his leg. Watch how the front of the deck flexes with each heel strike. That's the force of impact causing the deck to move, and that impact causes shock and all of the ill effects associated with it. Incidentally, what you're witnessing in the flexion of the deck is the Cybex Intelligent Suspension System, a system that greatly reduces shock. But we'll reserve Cybex treadmills for a future discussion. Because of shock and the overuse injuries resulting from it, manufacturers develop non-impact cardio or cross trainers. With most manufacturers, the design of their non-impact cardio trainers is modeled after the motion of the foot. Take a look at the green circle at the runner's ankle. It will allow us to track the path of the ankle as his foot moves through space. Ready? Here we go. What shape did the foot scribe as it moved from heel contact to heel contact? That's right, an ellipse. And thus, we had the basis for a whole new concept in cardio cross trainers, one which recreated running motion without the stress. But are ellipticals really stress-free? Let's examine one. Here's an illustration of an elliptical in use. The positions and proportions are all correct and accurate. On the elliptical, the flywheel at the rear of the machine rotates, moving the limb supports forward and backward while the foot plates move in the elliptical pattern. Notice the red line at the horizontal midpoint of the flywheel and the end of the limb support, also now highlighted in red, which is approaching that midpoint. Once the limb support reaches the midpoint of the flywheel, it will begin to move forward, as will the footplate which is attached to it. Until it reaches the midpoint, however, it and the footplate will continue to move backward, as you can tell from the illustration. Well, if the right side is moving backward, then logically the left side is moving forward. Not forward and up, as in stair climbing, but simply forward. The question is, how does the user manage this motion? One option would have the trail leg push the footplate backward, which would assist in pushing the opposite footplate forward. But look at the position of the subject's trail leg. It's straight, with the hip in full extension. She could press down with her trail foot, but that would mostly create a downward force with little contribution to backward motion. So the trail leg is really not in a position to move the footplates. That puts the onus on the lead leg, which must push the footplate forward in order to continue the movement cycle. The force for that push comes primarily from extension of the knee, creating quite a horizontal pedal reactive force. That force wants to flex the knee but extend the hip, resulting in very high loading of the knee extensors and virtually no loading of the hip extensors. In other words, all of the loading is placed on the knee, and at a point in the gait cycle when there is no such load during walking or running. According to one research study, these high quadriceps loads can create conditions that are potentially harmful to the patellofemoral soft tissues. They go on to say that one should use ellipticals with caution in order to avoid injury. The elliptical pattern may appear normal and lifelike, but the forces are abnormal and most certainly not stress-free. At Cybex, we approach cross-trainer design very differently. Rather than simply reproducing motion, we analyze it and decompose it. Running, for example, has two phases: the stance phase, from heel contact to toe off, and the swing phase, from toe off back to heel contact. The purpose of stance is to absorb the weight of the body on landing and to propel the body through space. Swing allows the leg to return to the ground in front of the runner. Watch here as the runner moves, first through the stance phase and then into swing. We've highlighted the swing phase, and as you see here, it comprises the entire top half of the ellipse. But the problem is that during swing, the leg is completely unloaded. No force is being transmitted through it, and very little force is required to complete the swing phase. So why build a machine that demands force output when none is naturally required? What if, instead of focusing on the unloaded component of running, we concentrated on the load-bearing phase? After all, we really don't need to duplicate motion. The central nervous system already knows how to resolve movements. What it's less adept at, on the other hand, is managing the forces to which it's exposed, especially those that create undue stress. So once again, our focus is on the stance phase, which we highlight for you here. And what motion path does the foot scribe now? Exactly, an arc. We took that pattern, tilted it slightly on its axis, and the result is the Cybex Arc Trainer. The most outstanding feature of the arc is that it manages force, not motion. In fact, through the use of highly sophisticated, instrumented foot plates, we've designed the arc to create a more vertical line of force that effectively bisects the leg, creating balanced torque loading at the knee and hip. By creating this line of force, we're able to activate not only the quadriceps muscles of the knee, but the powerful hip extensors, the glutes, and the critically important knee stabilizers, the hamstrings. The result is a machine that delivers biomechanically correct, non-impact exercise at up to 900 watts of power and 180 strides per minute. No other device can offer the arc's wide range of training options with its level of comfort and deliver comparable results, and independent research proves it. For instance, here are the results of a study conducted by the University of North Carolina at Charlotte. Investigators first compared perceived exertion on the arc trainer against a popular elliptical trainer at 55, 65, and 75% of subjects' maximal oxygen consumption. At each fixed metabolic workload, subjects reported higher perceived exertion on the elliptical than on the arc. Even though they were exercising at the same metabolic level, they thought they were working out much harder on the elliptical. In a follow-up study, the subjects recorded knee, hip, and back discomfort at 65% of their maximum oxygen consumption. This is a level at which most people are likely to exercise. As in the previous study, joint discomfort was significantly lower on the arc. What does this mean? Well, no matter how intensely you exercise, the arc will be more comfortable and less stressful. If users perceive lower exertion on the arc at fixed levels of oxygen consumption, then how much oxygen will they consume and how many calories will they burn when exercising at self-selected intensities? This was the question that was asked by researchers at the University of Wisconsin-La Crosse in a comparison of the arc, the Precor AMT, and the Precor EFX elliptical. The subjects were instructed to exercise for 30 minutes at their highest tolerable self-selected workload. This is the way in which most people adjust cardio machines. And the results were very interesting, but not surprising. Even though they were exercising at the same perceived intensity level, subjects consumed more oxygen on the arc than on the AMT or EFX. And over the 30 minutes of exercise, they also burned significantly more calories on the arc than either of the other two devices. In simple terms, for the same perceived effort, you get a much better payoff on the Arc. What happens when you combine balanced torque loading, high muscle power output, and high-intensity exercise on the Arc Trainer? Interestingly, something beyond a cardiovascular outcome. This was discovered at the Centers for Athletic Performance, whose subjects trained on the Arc 3 times per week for just 3 weeks in a high-intensity mode. Before and after training, they were tested to see how many repetitions they could complete on a leg press at 75% of their body weight. They were allowed no other lower body exercise during the entire training period. The results were compared against subjects who did general cardiovascular exercise over the same period. As you can see here, Arc-trained subjects increased their repetitions from 17 to 23, a 35% increase, while the control subjects showed no improvement. The Arc Trainer is not just a cardiovascular device. It improves muscular strength and endurance, too. Since the Arc Trainer is capable of delivering power levels up to 900 watts, the researchers at the Centers for Athletic Performance thought it would be interesting to see if that translated into functional power improvements. Once again, subjects trained using a high-intensity interval program 3 times per week for 3 weeks. They were tested on maximum hopping distance, a measure of force production, and on a maximum controlled leap in which they had to stick their landings, a measure of force absorption. Both tests were indicators of functional power. As you can see on the left, Arc-trained subjects demonstrated a significant increase in hopping distance, while general cardio control subjects showed no improvement. And on the right, it is evident that the Arc protocol helped improve their force absorption as well. Clearly, the Arc Trainer helps to promote functional power in addition to its other benefits. The scientists at the Centers for Athletic Performance didn't stop there. This time, they took a group of trained athletes and measured their 20-yard dash speed in feet per second. Half of the group did 6 weeks of high-intensity intervals on the Arc Trainer, while the other half did box leaps at intensities that produced comparable heart rates. Both groups showed some improvement in speed, but the Arc group had significantly better gains than an exercise which is customarily used to promote running speed. The Cybex Arc Trainer is truly a unique device that crosses the boundaries between cardiovascular, strength, and functional power training. It promotes high cardiorespiratory and muscular responses with less perceived effort or joint stress. It offers the greatest range of training intensities and burns more calories than ellipticals or variable motion trainers. The Arc improves muscular endurance, improves functional lower body power, and even improves running speed. All in all, the Arc Trainer is a product that delivers incomparable results.